I have a few of these digital calipers. I even bought one with a decent resolution, 0.01mm. For some time I was gathering information about the filament extruder that I want to build in order to recycle all of my 3D printed fails. One part of the extruder is the one that will measure the filament diameter, and will keep that always around 1.75mm, as usual filament does. So today I will use a digital caliper, I will read the measurement with a microcontroller, I will create a 3D printed support and measure the diameter of 3D printing filament with this device. I will use this part for a future filament extruder project. If I know the real diameter of the filament, I can increase or decrease the feed rate of the extrusion, and by that I can get thicker or thinner filament. In this same video, since we are working with digital calipers, I will try to explain how this works as well, and take a look inside it. I will show you how to get the data from it with the Arduino and display that to the serial monitor or to an LCD. But before we start, make sure that you hit the subscribe button, but don't forget about the notification bell, otherwise you will miss all my future videos. As always, a huge thank you to all my patrons for supporting my work. So let's get started. Video sponsored by JLC PCB. They have a new PCB batch production factory, more than 10,000 orders per day and 600,000 customers worldwide, and now offering the best prices. Ordering PCBs is very easy. Upload the Gerbers, select your settings and order PCBs for just $2. What's up my friends, welcome back. Here I have a digital caliper. This one has a resolution of 0.2mm, which is not that good for this project. That's why I bought this other one that is used to measure the depth and has a better resolution of 0.01mm, and that's great. With this one I could measure the filament of 1.75mm. Okay, so first thing first, let's take the opportunity and take a look inside, and I will explain how these calipers work. On the outside we have a place for the battery, and on this other cap for these 4 connectors. So I first remove the label on the back. Then I take out a few screws and now I open the plastic case. Do this carefully without damaging the board. I take a few more screws inside and now I could take out the board. On the main PCB we can see the chip that is protected below this black spot. We can see the place for the battery. We also have the pads for the push buttons and some pads here for the display. Now the main part is on the back of this PCB, and those are these very small copper pads. As you can see, this is a very small pattern of copper pads on the PCB. Now it's important to look on the other side as well. On the moving band we can also see some copper pads. I just removed the cover and as you can see, below this we have once again some copper pads, and the distance between these is always the same. So this goes like this. When these pads are in front of the other pads, they will create some very small capacitors. When the pads are exactly in front one of the other, the capacitance value will be at its maximum value. But when we are moving the plastic bar back and forth, the position of the pads won't be perfectly aligned, and the capacitance will get lower or higher, depending on the position. So all the microcontroller has to do is to count the capacitance peaks, and by that we could count steps, which are later translated into distance. This is a quite reliable and good precision measurement system. In order to measure the capacitance, the microcontroller could calculate the discharge rate of the capacitors, or just apply an oscillating signal and see how the frequency is changing due to the capacitance variations, since we could always use capacitors as a filter. Okay, so that's how the caliper works, more or less. Okay, so now the distance is printed onto this display, but at the same time we have these pads here on the PCB. I recently found that these are the I2c communication port that will send the data byte by byte. These pins are for ground, data, clock and power. Now we have to supply 3.3 volts, connect ground through a current limit resistors, and then read the serial data. I connect the serial pins to my oscilloscope and as you can see, I get the packs of data divided into bytes and this will represent each digit on the screen. All we have to do is to read these bytes, merge them together and get the real value. As you can see, when I move the caliper, the sent bytes will change since the measure value is also changing. So I solder some wires to the ground, the data, clock and power pins of the caliper PCB. On the breadboard I add a capacitor, a resistor and an LED following this schematic, and I connect this to my Arduino. The code will print the values on the serial monitor, but also to this LCD for this example, in order to show you how it works. I make the connections and now we upload this code. In the code I define the clock and data pins, and I define those as inputs because we will receive data from the caliper. Then we have the caliper read function. Inside this, if the data pin is high or low, we can add bits to our value since this is the received data from the caliper. Finally, I print that to the serial monitor and to the LCD screen, and that's it. I upload the code and let's give it a test. So as you can see, I now have the measurement onto the caliper, but also on the Arduino, and that's exactly what I need for this project, to read the value with the Arduino. Okay, so now I've designed and printed this support that is made for the smaller caliper. It has places for the bearings, for the caliper to be screwed in place, and for some Teflon tubes like these ones for the plastic filament. We will also need an elastic ribbon to pull back the caliper and push that against the filament. I first screw in place the small bearing here on this hole. Now I add the Teflon tube that will be later glued in place so it won't move. Now on the other side, I screw in place the caliper using 2 screws. I might add some more screws if this won't be strong enough. You have to solder the serial communication wires before screwing this in place, otherwise this might be difficult. I also solder wires to the on and off and 0 push buttons, in order to control this with the Arduino if I need to reset the value anytime. This will be very useful to set the starting value when measuring the filament of my extruder machine. Okay, so now what we have to do is to make a small hole just at the end of the caliper plastic band. Through this hole we now add another screw. Then I place the second small bearing on this screw, and between these 2 bearings the filament will pass. Put close enough the Teflon tube so the filament won't move too much, and be always in the middle of the bearings. Finally, I add that elastic band between this screw and the other 2 screws that are holding the caliper, and now the plastic bar will move automatically back and push against the filament. And that's it! Now the filament measuring device is ready and I could get the diameter of the filament. In this example I print that onto the LCD screen, but I hope I will be able to use this for the filament extrusion machine in the future project. By pulling faster or slower the filament while this is cooling down, I could control the diameter. But more about this in a future video. Okay guys, so for now we know how these capacitive digital calipers work, how to get the data using the serial communication these cheap modules have, and how to connect that to the Arduino. You could use this setup for any other measure process, for a different project if you want, now that you know how to get the data. You have the schematics and the codes below this video as always, and more information on my webpage electronoobs.com. You also have the 3D file for the caliper support if you want to make one. Also check the part list for the bearings and more. I hope that this video will help you and teach you something new. If so, consider subscribing. And please make sure that you activate the notification bell, because otherwise you won't receive notification when I upload a new video. Also consider supporting my work on Patreon. So thanks again and see you later guys.